Hey folks, we're going to look at some shapes today, specifically similar shapes, and the idea of the LSF. Let's go! So we should get our definitions out of the way first. Similar obviously has a meaning in English, which is that stuff that's sort of the same. In maths, it's got a slightly more rigorous definition, which is that two shapes are similar if and only if they are enlargements of each other. So if you could multiply the sides of a shape by 2 and get this shape over here, that would be a similar shape. You have enlarged it by this factor of 2. Or you could maybe divide it by 3, and that was also called an enlargement in maths, not an ensmallment. So that's the general idea. If it's the same shape but bigger or smaller, that is a similar shape. And we are going to focus on something called the linear scale factor today, or the LSF, which you can define as the length of the new side divided by the length of the old side. So say we had this first one here, say we knew this was 10 and we knew this was 2, then the LSF of this particular enlargement would be 10 divided by 2 would be 5. And it's just what are you multiplying the sides by to get from there to there. Let's look at another quick example. If we had this being 8 and this being 4, and we were working left to right, then the LSF would be new side, which is 4, divided by old side, which is 8. So your LSF would actually be a half there, because we are halving the size of that shape. So let's try one more. If I said that this was 6 going across here, and this was 2 going across here, then my LSF would be, so going from left to right, new shape, new side would be 2, old side would be 6, my LSF would be 1/3. So that's the basic idea there. So the main use of the LSF is for finding other missing sides on shapes. If you are told they are similar, then it's okay to do that. So we'll assume in the next 4 examples that we've been told these shapes are similar and that we need to find the missing side and the LSF. So here we are going from 3 to 6. So our LSF is 6/3, which is 2. And then if we want to find the other missing side, we need to times it by 2. So our missing side would be 10 centimeters. Seems fairly straightforward to me. What about this one here? What would our LSF be? Well, we're going from 3 to 9. So our LSF would be 9/3, which would be 3. That means we are multiplying by 3 to go from the old shape to the new shape, but that means we're dividing by 3 if we're going the other way. So our missing side here would be 5 centimeters. So another example, LSF, old side was 5, new side is 5, old side is 10. So our LSF is 5/10 is a half. That means we need to multiply by a half if we're going left to right. We need to divide by a half if we're going right to left. Now, to be fair, we could also have said dividing by 2 going left to right and timesing by 2 right to left. There's no rule that says you have to do the right side divided by the left side. We could have done 10/5 and thought about it the other way. Either way, we're going to get our missing side is 6 divided by 2, or 6 times a half is 3. Okay, one more then. So have a go, find out what your missing side is here, write down what your LSF is. Okay, so again, going left to right, our LSF would be 4/12, which would be 1/3. So I'm saying that to get from here to here, you times by 1/3. To get back, you divide by 1/3. Or again, we could have also said divide by 3 and times by 3. And so our missing side would be 6 centimeters. So that's the basic idea behind LSF, and I think that's something that intuitively you would already know what to do with. So if we call this question 1, I would like you to try and find the missing side lengths given the fact that these are all similar. Unpause the video when you're ready. You can use a calculator in 3, 2, 1. So for the first one, we should have got a LSF of 8 and the side is 32 centimeters. On the second one, our LSF was a 1/7, although we could also think about it as dividing by 7, and so our missing side is 2 centimeters. And on the third one, I decided to use the top shape as the new one. We're going to get 49.8/6, so our LSF is 8.3. And our missing sides there are 7 and 41.5. I've written down the sums that you would need to have used. Okay, so let's try and up this a little bit. So similar does not mean that the shapes are the same way round. It means they're the same shape, but they could have been rotated. And sometimes this will be happening and you need to make sure you know which side matches up with which side. So if we're looking at our first example here, we can see that they've sort of labeled the angles to help us out. So this angle here is the same as this angle here because they've both got two rings on them. And this angle in the bottom is the same as this green one here. So let's do a little bit of color coding. Now, if I want to find out what the LSF is here, I need to know what I'm matching up. And if we look at the 4 and we look at the 11.2, they're the two sides that are in between the green and the red. So if I want to get my LSF in this question, those are the two that I need to match up. So that'll give me 2.8. Then I need to think, well, what's that telling me? That's telling me that I need to multiply by 2.8 to get from bottom to top, from top to bottom rather. And so if I want to get this missing side here, then what I'm going to need to do is hopefully match it up with 3. Does it match up with 3? Yeah, because it's touching the green angle as well. I'm going to need to multiply by 2.8. I can get that missing side is 8.4. So you need to kind of like rotate the shape in your head and think about what side goes with what side. Could you have a go at the other two? Unpause when you're ready to have a look at the answers in 3, 2, 1. So for the second one, we should get the 49 and the 5 are the two sides that match up with each other. So our LSF is 9.8, and so our missing side is 58.8. And on the second one, it's the 8 and the 9.6 that match up, so we need to multiply or divide by 1.2 to get our missing sides. And we'll get our missing sides of 5 and 10.8. So yeah, really important to make sure you are matching up the sides when you're finding your LSF, otherwise you're just comparing some random side to some random side. So the majority of the rest of this is going through sort of examples of steadily increasing difficulty. We're starting off on grade 4 probably here with just simple find the LSF and find the missing side questions, and we're going to step all our way up to GCSE questions. On each one, pause, have a go, and then check the answers when you're ready. I'll unpause in 3, 2, 1. So for the first one, we should have got LSFs of 2 and 3 and missing sides of 8 and 2. Must remember my units, centimeters. Again, pause, have a go, come back when you're ready in 3, 2. So you have to go in both directions on these questions. We had to both multiply and divide. I think D in particular can present people with difficulties. If they get a number like 0.75, they're not necessarily intuitively sure whether they should times or divide by it. A good way obviously is just to check that if I got 0.75 here, that 8 times 0.75 does give me 6. If it doesn't, then I must need to divide between those two numbers. But yeah, do check your answers make sense. Like, we know the shape on the right is smaller, so E should be smaller than the 6 you started with, and F should be bigger than the 3.575 you started with. Okay, let's keep going. Once again, have a go. Come back when you think you're ready, and I'll unpause in 3, 2, 1. And there's your answers there. Again, decimal. LSFs, so just make sure that your answers make sense, that they get bigger when they should, that they get smaller when they should. Okay, let's keep going. So here's where we get to the actual this is a GCSE question, this is maybe grade 5 or probably grade 6. And it does say by drawing both triangles separately, and I will say this is a really important part of this process. If you try and do it without that, there are all kinds of mistakes that can creep into your method. So I'm going to go through probably 3A and 3B as examples, and I'd like you to try what 3C to see if it makes sense. So there are two triangles in question 3. There's one here, which has got a 6, 8 and a K, so let's just draw that separately. And then there's a bigger triangle, which is here. And what are the lengths of the bigger triangle? Well, it's got 10.5 on the bottom, we can see that. It's got like 12 here, so it doesn't have 8, it doesn't have 4, it's got both of those added together. And then on the other side here, we've got basically 6 plus J. Okay, so because it's both of those numbers combined. And it's really important that we set this up because you will get confused otherwise. Now, if we're wanting to do LSF here, we want to find the two sides that we know everything about, and we know everything about 8 and 12. So let's start with that. LSF 12 over 8 is 1.5. So we know to get from left to right, we times by 1.5, and to get from right to left, we divide by 1.5. What about the other sides? Well, let's do k first, because that one seems fairly straightforward. K is just equal to 10.5 divided by 1.5 is 7. That's something we've already done before. I think it's centimeters to be precise. And then there's the other one. So for this one, we're going from 6 to 6 plus j. And what we know is that if we do 6 times 1.5, we will get the missing side, the 6 plus j. So let's work out what that is. 6 times 1.5 is 9. So our missing side is 9 here. That's equal to 6 plus j. And so j must be equal to 3, because that's what you would add to 6 to get to 9. So you can see how now that this is a more complicated question. They're going to introduce some algebra into it, and also just generally thinking, do you know what your similar triangles are? And on B, there's another sort of similar situation to think about here. Which side would you match up with the 3? Okay, we're saying these are two of the same triangles, just one of them's been enlarged. Which one would you match up with the 3? Would you match up the 12, or would you match up the 9 on the bigger triangle? Well, what's actually the case here, and we can think about this with like alternate angles, that we've got a Z angle here. We've got two parallel lines, we've got something going between them. Those are the same angle. And similarly, we could say that these two are the same angle. That's another Z angle. And we could say that these two are the same angle. They're just opposite. So what matches up to what? Well, the 4.5, that's clearly between the orange and the green angles, as I draw there. The M, that's between the orange and the red, so that means it matches up with 12. And what's our last one then? So 3 matches up with 9. Now, is that what you thought? There's a tendency for people to go for the closest one, essentially. So when we're drawing out our triangles, again, we just have to be really careful that stuff matches up. So our first one, we'll have 3 and 4.5 and M. And our second one, make sure we match them up. So 3 goes with 9, N on the base, and then 12 over here. Once you've actually done that, it's not too bad, to be fair. Our length scale factor is just going from 3 to 9. So our LSF, let's draw it a little bit lower. Our LSF is equal to 9 over 3, which is just equal to 3. So that means we're obviously multiplying our side lengths by 3, or dividing by 3 if we go the other way. And so the other shapes are fairly straightforward. So like M is just going to be 12 divided by 3, which is 4. And N is going to be 4.5 times 3, which is 13.5. But you can see how that's going to throw people off. Right, you've seen the tricks there. I'd like you to try C. Unpause when you think you're ready. I'm going to do that in 3, 2, 1. So first off, there's the triangles you could have set up. Mistakes I would see people doing here would be just writing things like Q on the right-hand triangle here, or just having 1.6 on the right-hand triangle. Let's find the linear scale factor. So we should be directly comparing the 10 and 12 and getting an LSF of 1.2. For Q, if you go 6 times 1.2, you get your 7.2. So that means that the extra Q must be the extra 1.2 centimeters. And then for the bottom one, you actually get this sort of equation. If we times P by 1.2, then we'll get 1.2 lots of P plus 1.6. Oh wait, no, that's not quite true, is it? Sorry, because we'll just end up with P plus 1.6 because that's there. Whoops. Anyway, so this is an algebraic equation, and we should think if we've got P on its own, that's the same as saying we've got 1P. And to solve this, we're going to need to subtract P from both sides, and that will leave us with 0.2P is equal to 1.6, and then we could either divide by 0.2 or we could times by 5, and that would tell us that P is equal to 8 centimeters, I guess. So yeah, that last one, that's fairly tricky. So we're now up to like grade 6, I would say. Maybe grade 7. So there's a few more to try here. I'm not going to talk through these in quite the same detail, but it's using lots of the same tricks we just looked at, although I'd say these are probably a little bit easier. Have a go. Unpause when you think you're ready, and we'll come back in 3, 2, 1. Now first off, did you draw the diagram? Because the diagram is probably the single most important part of getting this right. Secondly, your linear scale factor is 10 over 3. And if you type that into your calculator, it goes 3.3 with a little dot, and there's a temptation to want to use 3.3 as your LSF, but please try and avoid that because that will give you rounding errors. You'd actually get an answer of like 24.8 or something. We need to use exact linear scale factors, so we'll use 10 over 3. You know, calculators have a fraction button, we may as well use it. Okay, on to the second one. Okay, that felt a little bit more straightforward to me. Don't forget your units are millimeters. And then third one. Yeah, it's another 1.25, and we got 12.5 meters this time for our x. Okay, 3 more of the same. So we looked at ones like these on the previous set of examples. Remember that we've got these z angles, and so it's not the case that, for example, 12 goes to 26. It's the case that 12 goes to x and y goes to 26, because we can say that our angles look something like that, and you could say the same for all 3 of these. Okay, have a go. I'll pause when you think you're ready. Have a look back at the question 3 examples if you're stuck, and I'll show you the answers in 3, 2. So it's actually quite a nice just times divide by 2, that one. We've got 24 and 13 meters for both of those. Second one. Again, make sure your diagram's right. Y needs to go with 6 and 9 needs to go with 15. And we should get a linear scale factor of 5/3. Again, don't round that. It's like 1.666, but why bother? Just use 5/3. You get that x is 6 and y is 10. And then the last one. Again, make sure you do your triangles right. X goes with 6 and y goes with 9. And you get the same scale factor, but obviously we're using it a little bit differently. So we get x is 3.6 and y is 15. Okay. So what could we do past this? So these last 5 questions are very much in the GCSE grade 6 and above zone. If you have time, it would be a good idea to see how far you can get with these. But obviously it's a 70-minute lesson. Do what you can do in that time, but I'd expect you to get up to this point. Again, there's nothing new to teach you, I think, at this stage. So have a go, see what you get, and unpause when you're ready. So what stands out to me on this one is that it wants you to find the length of BD, which is just this bit of the line. So we'll call that x, and then the whole length of our triangles here is going to be 4 plus x. So we're then going to do that the LSF is 9 over 6, I guess, which will be 1.5. That means that to get from left to right, we need to multiply by 1.5. So let's now compare our 4 with our 4 plus x. If we did 4 times 1.5, that would be 6, and that would be equal to our 4 plus x. So that means that x is equal to 2. So that means that BD, the thing we're after, is 2 centimeters. This one's an interesting question because it turns around the definition. It asks us if these 2 rectangles are mathematically similar and justify your answer. Now go back to the very first thing we wrote down. What does similar mean? And you want to try and get that definition in here. So unpause in 3, 2, 1. So remember that similar means that we multiply all the sides by the same amount to get the new sides. And what we can do here is we can find 2 different values for the linear scale factor. We can get a value of 2 if we do 20 divided by 10, and we can get a value of 1.6 recurring if we do 25 divided by 15. I have actually put this one as a decimal just so it's easy to see that those are different numbers. So our working has been basically shown at this stage, and we could just tick no, but let's put an explanation on there as well and say that the lengths are not multiplied by the same amount. Cool. 3 to go. We're going to get into some seriously tricky territory now. Okay, taken straight from a GCSE paper, although I think you'll know what you're doing with this one. Just draw out your 2 triangles. We want to find the length of AB, so that's this one here, and we want to find the length of ED, which is this one here. I would recommend calling that like X or something. Okay, over to you. So for starters there, we can get that the LSF is 2.25. We can get that the missing side AB, we need to divide by that, so we're going to get 5.2 for that. I guess I should say centimeters because it's a unit. And then we've got again this 4 to 4 plus x thing. So what do we know? We know that if we multiply 4 by 2.25, then we're going to get ourselves to not 10 but 9. And that's going to be equal to our 4 plus x, so that tells us that x is 5, and that was our ED that we were trying to find. So AB, that's going to be equal to 5.2 centimeters, and ED, that's just going to be equal to 5 centimeters. Cool. 2 more to go. So this is a tricky one. We're told that SR is parallel to PT. This is another of those questions where like you'd match up this side with this side and vice versa. But we're actually not told those in this side. We're just told the total height of the triangles is 40 and that we need to try and find what H actually is. So we can draw some very rough triangles, which will just be like 20 and 30, and we can easily get from that the linear scale factor is 30 over 20, which is 1.5, because, well, they're the only two sides to think about. So what else could we do? Well, we can say that this distance up here is h, because, well, it tells us on the diagram that it is. And we know if we divide that by 1.5, we'll get the value that's inside the other triangle. So we get, if we do 20, no, not 20, if we do h divided by 1.5, so what's the same as dividing by 1.5? If I go 1 divided by 1.5, it gives me 2/3. So maybe that's another way of thinking about it. Maybe we say instead of times it by 1.5, this could be 3 over 2. And this could be the same as dividing by 3 over 2 or timesing by 2/3. Either way, you would get that this value here, this length, is 2/3 of h. Now, what's the point of that? Well, we can fill that in on the diagram. We can say this is 2/3 of h, and we know that all of that put together gives us 40 centimeters. So a h plus another 2/3 of h is going to give us 40. What's 1 plus 2/3? Well, that's 5/3. So we can say 5/3 of h is 40. And then that is just some algebra that we can solve by dividing by 5/3. And we could get that h is 24. And we could then check if that works. So if we say h is 24, we can say this is 24, and then they have to add up to 40, so this is 16. Is 16 2/3 of 24? So yes, because 24 divided by 3 times 2 is 16. Do we get 16 times 1.5 gives you 24? Yes. So yeah, that is very definitely a grade 7 question, because we had to first realize it was similar triangles, then we had to come up with some algebra, and we had to solve the algebra. But I have actually managed to find one question even more tricky than that. But again, only go on to this if you've still got time. So behold, the pentagons. The question is we want to work out the width of the badge, and I'm going to take the width to mean find the value of x. Find the value of 3x, because that's the whole badge, isn't it? Yeah. So yeah, first mistake there. We have got two similar pentagons, so we can sort of draw these two next to each other. Again, by the way, if you want to have a go at this, unpause at any time and have a go. Or pause at any time and have a go. I'm just going to talk through it, I think, because it's the last one. So we've got x here and we've got 3x here. And we've also got 36 here, and we've got x plus 4 here. And I think it's fairly straightforward to find the LSF, because we go from x to 3x. So our LSF is 3x divided by x, which is just 3. You know, this clearly times is by 3 to get to 3x. So we must divide by 3 to go the other way. So let's think about that. Well, that would tell us that 36 divided by 3 gives you 12. Which is equal to our x plus 4 over here. So let's take away the 4, and then we can get that x is 8. No, that wasn't too bad. What's the width of our badge? It's 3x, so 3 times 8, which is 24 centimeters. You could check this stuff works if you wanted. You could fill in that that's 24, that's 8, that's 12. And you can clearly see, yeah, we had to multiply 8 by 3 to get to 24. We had to multiply 12 by 3 to get to 36. But yeah, that is, I think, the most difficult one of these questions that I could ask you. And amazing well done if you managed to get any of those last couple correct without my help. Cheers.